Hey guys, we're going to do some graphing calculator stuff today. So you want to get your graphing calculator out. So you might hit pause and go grab that. And I'm going to show you some kind of neat stuff in using polar equations on the graphing calculator. I'm going back to our notes from the other day just to pick up some problems. Let's start with this guy right here. So in example 4 in the last set of notes, in part A, we had to take this conic section, which was a circle, and change it to a polar equation. And so we had several steps for that. And we ended up with r equals 8 cosine theta. So I'm just going to show you how to enter that on your calculator. So the first thing we want to do is go to mode. And if you go down to, it looks like the 5th line, and I'm going to assume you can see my cursor here. Right now it's in function form, which that's really a rectangular equation. So I'm going to go down here, and the next one is parametric, and then the next one is polar. And so I want to click enter on that, and now I'm going to be in polar form. And we're going to quit. And so now when I hit y equals, you can see that it says r equals, okay, which is how our polar equations start. Then I want to go to my window, because it depends if you've reset this and you're at Windows, it should all be the same. But you'll see that theta, now we add a theta constraint here. And so this is 0 to 6.28 because we are in radian mode. And that's just 0 to 2 pi. That's what that's equivalent to. And you can change here if you want to change your steps, like how much your angles are. So if I go down, I know it's in decimal form right now, but you can certainly do it how we would normally. On our graph, it looks like we're going every pi over 12, so you might want to put that. You could go every pi over 6 units if you wanted to, which that's fine as well, but you might not get that pi over 4 that you want to see. Let's see what happens. So there's pi divided by 12. You might be hearing some little humans in the background, and that's okay. And so we've got pi over 12 there. And then my x and y, so that's still how much I go horizontally left and right and how much I go vertically left and right. And so this is going to determine my radius. So I'm going to keep these the same. This is going to go 10 units. And you'll notice that my x's and my y's are the same here. Now, if you know you're going to have an ellipse, which one is thinner than the, or more narrow than the other, then you might change your x and y's, but this is perfectly fine here. And so I'm going to go back to my y equals, and I'm going to enter my equation, and that was 8. And then cosine theta, we're getting all of the sound effects. That was a dog sneeze. And I'm going to graph. Okay, so I know this is a circle, but it looks like an ellipse here, and that's because if you look, your x's and your y's don't have the same spacing. So I'm going to go to zoom, and I'm going to go down to number 5, which says square. And so that's going to square off our graph. And you can either hit 5 or you can cursor down to that. We'll hit enter, and now it's squaring it up. Our spacing in between is the same, and so you can see we have our circle, and if you wanted to trace that circle, you could. I'm just going to go using my left and right button, and we're going around, and you can see the different increments. So that's how we enter a graph there. Let's go back and look at, actually I'm going to look at 5b as our example. And this is just says r equals 4, and we know that's a circle. So I'm going to clear out of that, and I'm doing r equals 4, and we'll hit enter. So it should have a center at 0, 0, and a radius of 4. And there we go. And it's already squared up, but if you haven't done that, you can go to Zoom and square, and that'll square it up, and there's our circle. Now on the I'm just going to leave this one on here for a minute. On the previous problem, it says theta equals pi over 6. So even though I cannot really graph this in polar form, I can figure out what my graph would look like based on a circle. So you can put any circle you want in there. You just say r equals and give it a radius. It doesn't even matter. Then I'm going to go to calc, so second trace, and I'm going to pick a value. And it's going to let me, you see down here, it lets me choose what I want for theta, which is in part A on that example was a over 6, or pi over 6, sorry. So we're going to hit pi divided by 6 and hit enter. And it's going to show me where that point would be. And you can see that little cursor. So now here's my coordinates. I've got 3.46 and y is 2. So those are my coordinates there. That's my radius. And theta. And so if I were to take that particular point on my graph, okay, and I were to go from 0, 0 and draw a line through it, that's where my graph would be. And I don't think I can draw over this, but that's where it would be if I go from 0, 0 through that point, draw a line through those 2 points. That's where the graph of my line pi over 6 would be. Theta equals pi over 6.